Okay, cool. Let's start. Uh, Good night, everyone. I'm Imbre. I'm currently working as a cloud platform engineer in Gojek. If you never heard of Gojek, Gojek is actually one company in Indonesia that provides several services like ride hailing and then food delivery and logistic and many things. So apart from that, I'm also a Google developer expert in cloud. And I'm from Indonesia, especially in Jakarta. I also see some familiar name from Jakarta joining this meetup. But I want to say thank you, especially for Go community in Sri Lanka to invite me to talk here. Tonight, we're gonna talk about how we're gonna write a better test in Go. So this is actually a really opinionated talk, and then this is completely based on my experience and what I think is the best way to write a test, or probably maybe you have a better idea about how to write tests. But if you have any question or want to give feedback, feel free to do it in the middle of the session or probably after the session. So let's start. So we're gonna start talking about what is a unit testing. So unit testing is something like low-level test that try to ensure the behavior of the functionality that we are trying to build. It basically operates on several things like method, classes, small number of collaborating classes. So when you're writing unit tests, probably you want to test a method, a function, a method, and probably you want to test a class. Probably you want to ensure that the class has a certain behavior. And probably if that function has collaborating classes, like if you have dependency injection, if you have function that have uh, another interface injected to that function, you want to ensure the behavior of the test as well. So that's basically unit test. Probably most of you already heard of unit test and know about it. And then in Go, actually writing test is really simple. So what you need to do first, you're gonna have to define a package name. If you have package simple, and then you're gonna give a underscore test suffix. This is just to ensure that your test code doesn't go to the production binary or production build. And then you import a package name testing. And if you want to test something, you basically can do assertion. So in here, we have, you want to ensure whether 2 is not equal to 3. And then if it's fulfill this condition, and then we're gonna make it fail because we know that 2 is not equal to 3. And then this is how usually people natively write tests in Go. We're gonna have to write if, and then inside it we're gonna have to do assertion. And actually, in my opinion, only idealists write tests this way, because right now we know that a lot of assertion framework that we can use, or probably library that we can use. Before we talk about that, I'm gonna give you a brief explanation about unit testing principles. So actually, there are 11 principles that I usually keep in mind while writing tests. But tonight we're gonna talk about just 2 of them, because this probably take hours if we want to give complete example. But tonight we're gonna talk especially about maintainability and determinism. Why this important? I'm gonna explain it later. But apart from this, there are several principles that I usually follow. Something like how we're gonna ensure that unit test that we have is can be executed really fast. Because if you have really big application, and probably you're gonna have hundreds of thousands unit tests inside of it, and then you want to ensure that every time you make small changes, you want to ensure that all of the tests still pass. So in order to do so, you have to be able to run the test less than 1 minute. So that's why unit tests must be really fast. Apart from that, we also talk about simplicity, how tests should be simple, and understandability, so that people can understand what you're trying to explain on the test, because test is also another code that we need to maintain. And there are a lot of other principles that we need to follow: single purpose, behavior first, independence, fallibility, and comprehensiveness. Probably, hopefully, we will be able to explain this later on another session. But tonight we're gonna start talking about maintainability. So why maintainability is important is actually because, as I said, code is unit test is also code that we have to maintain. If you have new developers coming to your team, and then you want to ensure that they understand what test that you're writing, and that's why maintainability is important. So the first situation that I usually try to avoid is putting conditional logic inside the test. So if you see here, I have a test. Basically, I have a function that I want to test called getMap. And then what this test is actually doing, they want to ensure that this map that returned by this function has key A and key B with the respective value of A and value of B. So if you follow the traditional way of writing tests in Go, you're gonna have to do something like this, right? You check whether the value is there. If it's not, and then you're gonna fail the test, because it's really important that a test can be failed. So you do it here, and then you if after you got the value, you want to assert that value by checking if A is not equal to value of A, and then it's gonna be failed. It's gonna be same for B and value of B. You're gonna have to do something like this, but because if we do it this way, it's gonna be difficult for us to read the test and to maintain the test in the future. So what we can do, we usually use assertion framework. So in Go, there is a famous assertion library called Testify. I usually use this because its API is pretty simple and it's enough for writing unit tests or even integration tests. So how we're gonna refactor the code that we created earlier is by doing it this way. So we're gonna check whether this map contains A. So we use assert contains TMA to ensure that A exists on this map. If it exists, we're gonna go to the next assertion to ensure that the value of key A equal to value of A. But what if A doesn't exist on the map? So this assertion will immediately fail the test. So we don't really have to check this if the first condition is failed. So it's gonna be the same for B and value of B. So that's how we're gonna use assertion framework to make the unit test that we write simple. And then, yeah, because again, people expect to understand your code from reading the test. If you don't have tests, probably people will have to go to your implementation and then see what the code is actually doing. But if you have tests, they can just read the test and know what this test is trying to do by reading the input and expecting the output, something like that. And the next thing about writing tests is testing is not about achieving 100% code coverage. Testing for me is more like how we're gonna define the input space of the test. It's similar like test cases. If you have a function, how you're gonna define the input that you're gonna use against the function and what the expected outcome is gonna be. And in doing so, actually in test, there are two practices. The first one is doing black box testing, where you don't really know the internal implementation. So what you know in this case is the requirement itself. So it's like business requirement. Let's say something like login to the application. You know that when you inserting a new correct username and correct password, you should be able to log in. If you provide the incorrect one, you will not be able to log in. So that's how we're gonna do black box testing. In the other hand, there is another test called white box testing. So in this case, as a developer, you should know what the internal implementation looks like. If you have a function, you know what the parameters that function will accept. And that's how we're gonna define the input space for the function. But if we have a lot of test cases, let's say for a function, how do we manage that? In Go, there are several ways. We're gonna go through two of them. The first one, I'll give you this simple function. So if you see here, I have a function, and this function accept A comma B, and it return integer. So I have this simple implementation, A per B. So I need to get the value A divided by B. And this is all of the test cases that I have. For the first test cases, I'm gonna have A equal to 1, B equal to 2, A equal to 4, and B equal to 2, and so on. But is it the correct way? Is it the better way to manage all of the test cases? If I have, let's say, 100 test cases, 100 different test cases, should I do it this way? Probably not. So what we can do is using table test driven. So in Go, there is a concept called table test, where you basically create something like table that you will iterate to check whether the input that you give on the test is equal, the output of the function is equal with the value that you expect. Something like that. So I have a test diff here. This is how we usually define test in Go, right? You provide a testing T struct in here. And then this is the test table. So actually, it's going to be array of struct. You don't really have to define the struct outside this function with a specific name. You just need to do it this way. If you are using Golang or something like advanced IDE, you probably will be able to generate all of them so you don't really have to type everything. But for a simple case, like the testing diff function that we just created, I'm gonna create a test table here, the input a comma b, which is integer, and the expected value. So since this is array, so I'm just gonna define all of the value. So the first test cases will be a equal to 1, b equal to 0, and the expected value is 0. And the second test cases is a equal to 2, b 1, expected 2. And then what I'm gonna do here, So what I'm gonna do here, I'm gonna iterate over all of the test cases, and then I run assertion here. So I just need to write one assertion, assert equal, give the t, and then the expected value, and execute the function here. By having this, if I found test cases that fail, and then I'm gonna get fail information on the terminal, something like that. But can you spot what could be confusing here? If we go here, so we know that if we have a value and we divide it by 0, the result will be error because it's not a number, right? But in this case, I have a 1 and b 0, and here I expect the output of the value is 0. This should return error. However, if we write the test this way, we never know which test cases that will be fail, because Go will just tell you that this line, this assert equal, is returning result that we don't expect, but we don't know which test cases. So there is before we talk about the solution, there is a subtest that I would like to introduce if you never heard of this before. By using subtest, basically, it helps you manage the test under the same logical group. So let's say I have a test random, I do some preparation, and I defer a cleanup function. And then I create a subtest by using this way. So you see here, I have t, and then I just need to call t.run, and I provide a name, and then I get another closure with accept testing.t. And inside of this, I can do whatever I want. I can create another subtest, and I can create table tests, and so on. So, sorry. So in here, what you will see that probably we can create a test for positive cases. And here we can create a test for negative cases. So we can group all of the test cases that we have into the same logical condition or case. And how are we going to improve the test that we created earlier? So it's easy. If we combine test table and subtest, we're going to have something like this. So we're going to provide the name of the test. Let's say name here, and then we're going to give it name, test division with 0, and then positive numbers division. And then when we iterate, we're going to create subtests for each case. So this is how I usually do it. T.run, and I provide the name, and I get another closure. If this assertion is failed, I know immediately that which test cases that fail because I provide the name here. So that's really easy way that we can do to create the tests more maintainable. And when should we use test table and when should we use subtest? So rule of thumb for me, usually I will use test table for simple input-output function with a lot of test cases. So let's say that I have a function for test the value of a square root. So I just need to provide the input space, and then I will give the expected outcome. But I usually will use subtest if I have more complex tests where I have several mocks that I need to set up prior to do assertion. So that's how I usually subtest, because when you create a mock, I'm gonna show it to you. When we create mock, we probably gonna have to define the behavior of the mock, and then we define how many times the mock will be called, and so on and so forth. So that's gonna be more complex. So that's why I usually use subtests when I want to write tests that is more complex. And the second principle that I would like to talk is about determinism. So in determinism, the key is tests should not fail at random. So what we need to do if we have unit tests, that we have to isolate all of the source of non-determinism. For the example, it's gonna be network issue, where you make a call to database. Let's say you have a database in cloud, and during the unit test you call that database, and it probably gonna be failed because sometimes something that can be failed will be failed. So that's why we need to isolate or even remove that from the test. How are we gonna do that? I'm gonna show it to you later. Another thing apart from database call is third-party API. So if you're calling, let's say, Google API or AWS API and so on, it's gonna be a source of non-determinism. So we need to isolate them. And if you have random, let's say you are creating a test that using random numbers that you cannot expect what the value is gonna be. So it's gonna be the source of non-determinism as well. So there are a lot of source of non-determinism, but I think I'm gonna show you just network issue with database call or probably third-party API and what we can do to isolate and remove that. So in here, assuming that I have a DB call. So if you see here, I have a DB call, database repository layer, so name user fetcher, and then I have a struct of DB connection in here. I should say that this is a source of non-determinism because if you're creating a real connection, you're gonna have to create a connection pool, and sometimes the connection pool might return error because of the network issue that I mentioned earlier. And if you see here, there is a function find by ID which accepts string and return a struct of user. And then what you do here, you call the DB connection and then you give a condition where ID is equal to ID that you just passed, and then you get the first result and then you return it. And I think there is a way that we can do to improve this test so that we don't really have to create a real connection. I think you already know we probably gonna use a mock, but how we gonna create mock for database call? There is also another opinion that if we want to test database, why not writing integration tests, which directly call DB? That's not wrong, actually. But again, if we talk about another principle that I mentioned earlier about speed, when we run the test, we really want to get the result in less than 10 milliseconds, just for one test cases. So if we make a integration test which calls DB, and then it's gonna spend more than that, probably 200 millisecond or 300 millisecond or even more. And we don't want to do that because when we write code or when we make small changes, we want to get faster feedback, right? So I think writing integration tests, if we want to get faster feedback, is not really feasible here. So that's why instead of doing it, we're gonna go with mock. So we're gonna mock the connection so that we can test whether the query that we want is correct or not. So that's how we're gonna do that. Before we talk about that, probably you ever heard about test double concept. It's like a stuntman in Hollywood movie or even other movie. So when we want to create a test, we don't really give the real implementation of the collaborating class. So we give the fake or mock. So there are 4 types: test double, mock, fake, spy, and stop. I'm sorry. Give me a sec. This usually happen. Okay, so probably you can search for the meaning for each of it later after this talk. But tonight I'm gonna focus more on mock. So what's special about mock is that you can define the behavior of the collaborating class or the class that you want to use during runtime. So let's say you have a mock for this database. You can define how this database call will behave if we give certain input. If we give, let's say, if I give ID equal to A, I'm gonna get result like this. If I give different ID, I'm gonna get different result, and I can set that during runtime. That's really special about mock. If we talk about fake, you're gonna have to define the behavior of the fake earlier, so you cannot really change it during runtime. Oh, I'm sorry. This is how we're gonna create mock for database. So we are usually using Go SQL mock, and then you can choose any driver like Postgres or MySQL or other type of SQL driver if you are using SQL. But the key here is that you're gonna have to create mock of the real DB connection. So it's not gonna be real, so it's gonna be mock. You actually mocking the DB connection by call the skl mock.new. So this is a package provided by Datadog. And then from this function, you're gonna get skldb and mock. And in here, because I'm using GORM here, GORM is the ORM in Go, one of the ORM that you can use. I will just pass the skldb to the connection of GORM here. So if you see here, I create a connection and I give the skldb, which is a mock which is fake connection to the GORM. So here I will get the GORM and then I will be able to use it. I will be able to inject that to the repository layer that I showed you earlier. And this is how we're gonna do that. This is how we're gonna test the user fetcher function. I call the mock, I get the fake DB connection, and then if I get it, and then I pass it to the user fetcher here, you see here, I pass the mock instead of the real connection. So here I don't connect to any real database like Postgres or MySQL, I just create the mock. And in here, I will be able to get the user fetcher object so that I can call find by ID and I give value 1 here. So what this mock is actually do is, if this function is called, I'm gonna expect that the DB connection will execute query like this. So I'm gonna do assertion with the what query that it will generate and execute if I give real connection. So in here, I'll expect that query will be select star from users where ID is equal to an argument. So I'm able to pass the argument as well if I want, but if I don't want to pass it, it's okay. And I will be able to tell this function if this query is being called, I'm gonna return a result, which is result that I defined here. So it's ID, name, and then I give the add row 1 Imre. So if I call this function, this query will get executed and it will return this result. So you can also control whether you want to return a rows or you want to return error if you're using mock. So you don't really have to make a real DB connection. And here again, if we have tests, we always we should and we must validate whether the result that we got is expected. So that's how we're gonna do it. We call no error, and then I expect there is no error from this function because I return a result. And then I'm gonna expect the value of user.name is equal to the value that I return here. So this is something that I'm gonna do if I want to write the assertion for this simple function. But apart from that, I also need to call mock expectation were met. So this is some sort of verification that we want to run because we want to ensure that the mock that we have here is actually calling the right query and using the right argument. So let's say if I change here with argument 2, but in here I give 1, when this function is being executed, they're gonna return error because the argument that they expect is not equal with the value that I give here. So this is why verification for the function that we want to test and also the mock is also important. So here we validate the result of the entity under test, but in here we also expect the mock behave as expected. Something like that. So we just talked about how we're gonna mock DB connection, but right now I'm gonna talk about how we're gonna mock the collaborator. If we have other API services, let's say you are developing an order service, right, which has dependency to payment service. So payment service has been implemented in another work, probably by another team or even other company, but you have no control over the service. But what you have is control over the order service, but you have no control over the payment service. So the least you know is the interface of payment service. So this is the interface. The payment service has a function which is generate invoice. Order ID, it accept order ID, and then it return invoice and error. So this is all we know about this function. But what we can do if we want to test a function that internally use this API. So let's check the entity under test. So I have order service, which has association to payment service here. And I have a function called finalize an order, and I provide the order ID. And here I will return string, which is gonna be the invoice URL and error if any error access. So here I do some setup, and then eventually I'm gonna call o.payment service.generate invoice, because again, we don't want to make real connection to the third party. We're gonna have to find a way to mock this. So this payment service is gonna be a good candidate for mock. So that's something that we're gonna do after this. In here, if you got the invoice, and then you will be able to return the invoice.url command nil if there is no error. And the question is how we gonna control when the payment service generate invoice should success or error. That's how mocks come handy. So we're gonna create mock. Again, creating mock is simple. If you want to create mock, actually you can also generate it by using the interface. It's simple, but I suggest you to try to write it by yourself instead of writing generator so that you know what the mock actually does. So in here, I create payment service mock. Here, I inherit mock.mock struct here. And then what I'm going to do, I'm going to define the implementation of the interface for the payment service. So this is payment service mock, and generate invoice which accepts string and return string comma error is the signature of the payment service. So we're going to mock this function. And what we're going to do, we're going to do something like this. m.call, we provide the ID here. This will be used later for verification for the mock. And then we're going to return string for the first argument, and we're going to return the error for the second argument. I mean the second first output and second output here. This is how simple to write mock. So I suggest you to try this out. Let's create an interface and then write a simple implementation of the mock and then use it on your test. And the test itself, we have test finalize. We need to define, we need to instantiate the mock by calling new function, new payment service mock. And then here, this is how we're gonna use the mock. This is defined by m.on. When a function named generate invoice is being called with any argument, mock anything, this mock should return a value. In this case, it's gonna be, wait, I think I put it wrong signature. Oh yeah, I do it incorrect. But this should be an invoice object instead of string. I'm sorry, I'm gonna fix it later. So when generate invoice is being called, what I want to return an invoice here. But let's assume that I'm returning invoice which has URL inside of it, and then I have nil here. And then when I have the order service and I call order service finalized with 1, 2, 3, 4, and then I'm gonna expect there is no error that I get from this service because the mock that I create return nil as error. But because the finalize function that I show you here is returning the invoice.url, so I should expect that the finalize function here will return the URL. So this is how we're gonna control the behavior of the payment service while we don't really implement it. So we are using mock. We provide the return value of the mock function itself. And then if we want to return error, it's gonna be similar, but we just need to change the return value. In this case, we return the invoice and return nil because we want to get the URL. But in case we want to get error, you just need to return nil invoice and then return error. Because here in the implementation, if we get error, we're gonna return empty string comma error, and then later on we will be able to assert that. So that's how we create mock. Another good thing about mock, if you're using mock for more advanced feature, there are several things that you can do. You can limit how many times mock return data. In a function, probably there will be iteration that in each iteration, it try to call third-party API. And then we can limit how many times the mock should return the value. So in this case, I will say that this generate invoice should only return this result 2 times if I do it this way. Other than this, I can also set a response delay to a mock. So let's say I want to simulate whether payment service has an issue, and I want to ensure that my function that is using the generate invoice doesn't have a severe impact. So what I can do, I can set a response delay to the mock. So what I'm gonna do here, I will call generate invoice mock, and then I return this, but I'm gonna return this after 5 time seconds. So I can simulate 5 seconds of delay when I calling this generate invoice, something like that. And then there is another thing that you can do as well. Actually, when you run the mock is not, the function is not executed. So it's just telling you that the result is gonna be here, something like this. But if you want to execute something like side effect, you can also do that by calling function run and then provide a closure, and then you specify what you want to do. In here, if I call generate invoice, apart from returning this result, I will also be able to run let's say a code or logic. In here, I just print something to the terminal. So this is a side effect that you can also use. the next thing is about what we need to verify if we are using mock. So if you see earlier this m.on, there we using mock.anything, right? In that case, we don't really care about what value is being used when we call this function. But we can also check whether the value that we give to the mock is also correct or not. So we can provide the exact value here, and then we're gonna call assert expectation to ensure that when we call this mock, the value is exactly 1, 2, 3, 4. Because in here we provide 1, 2, 3, 4, and then here, because we don't have any processing, we will expect the value here will be the same. But before you call this function, you do some processing. Let's say you add any prefix to the function. When you call 1, 2, 3, 4, and then you're gonna expect that this generate invoice will be called by 1, 2, 3, 4 dash blah 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 blah, and then you can also do some assertion for that by calling this assert expectation. So that's all. Apart from asserting the function, you need to verify whether the mock is using the right parameter or not. Hopefully that's clear enough. And if we talk about more complex verification, let's say you want to if you have mock, let's say create pinpoint here, and then the value unfortunately is not primitive, so you cannot exactly do provide the object, but you can use function name mock match by here, and then you can assert some value of that location. So let's say you want to check whether the location that you want to use on this create pinpoint is having the right value or not. Let's say I want to ensure that the location name is not empty and the location address is equal to 1600 Villa Street. We can also verify it this way if you don't want to verify all of the properties inside the location. Let's say location has 100 properties and you just care 2 of them. So you can do something like this. This is complex verification. And I think this is gonna be the last part. Yeah. You probably see that on the previous slide that we always have interface that we can mock, right? In here we have payment service interface. And then here we also have another interface. Where is that? In here, location service interface that we are using in our function. But what if we are using third-party API with no interface? So let's say if you are using AWS SDK only provide you with the struct, so they don't provide you with the client. They don't provide you with the interface. So what to be mocked here? Let's go with this example first. This is user services where I have uploader, which is AWS S3 client. And then here I have upload profile, and I give the user, I have a function called upload profile, and then I get the user data and then the picture in byte, array of byte, slice of byte. And what I do inside this function is calling a function called put object, which is a function of AWS S3. In this case, it's gonna be hard to test this function because there is no way for us to test this function other than injecting real AWS S3 connection. But we don't want to do that. We don't want to do that because it's gonna time consuming and it's gonna spend more time rather than running fast unit tests. So what we can do, there is a concept in Go that you probably ever heard before. It's called duck typing. If it quacks like a duck, and then it is a duck. What does it mean? So there is no need for explicitly saying that a struct is implementing an interface. Let's say if I have a struct and I have an interface, I don't really have to explicitly saying that this class implement this interface. What I need to do is only making a function or method that mimic that interface. Without defining it, I will be able to use that struct exactly for that interface. So there is no need for explicitly saying that a struct is implementing an interface to act as that interface. So it's called duck typing. So what we can do, actually, if you go to the documentation, AWS S3 has a lot of methods, probably more than 20 or 30 methods. But because in our function, we only need one, so we will just create one interface. One interface with one function. In here, I have uploader interface, and then I have a function here, put object, which I use inside the uploader function that I showed you earlier. So what I'm gonna do next, I'm gonna change the association. Instead of accepting AWS S3 client here, I will put this interface here. So what I can do, because this is already interface, And because AWS S3 client already satisfy this implementation, and then we can change it during the test and during the runtime. So if we want to run the test, we're gonna change it with the mock, and if we want to run the production code, we will change it with the real AWS S3 client. So this is how we're gonna use the concept of duck typing in Go. We provide the interface, just one. If you go to the documentation, you will see S3 client has a lot of function, but here I just care one of them. And then here I give the user service uploader, and then what I need to do, same as before, I'm gonna define the mock. So this is how I'm gonna define the mock for S3. I'm gonna inherit the mock.mock struct from the testify, and then I'm gonna create simple implementation of the mock by call the input, and then I'm gonna return the argument 0 with put object output, and then I'm gonna return the next argument with error. So this is how I'm gonna define the mock, and then when we write the test, we just need to create the mock of the S3, and then we pass the mock here to the service up to the user service. If you see here, the uploader here is accepting M instead of real AWS S3 connection. And here again, I should be able to define the behavior of the mock by saying that if put object is being called, I want to return this object, but I want to ensure that the properties captured by this mock is also being asserted by doing it this way. So I call mock.matchBy again, and then I give the input, and then here I do assertion by checking whether the key of the input is equal to Imbre, because on the implementation here I do it this way. Key here is equal to the user.name. So on the test, in here, I call upload profile with username equal to Imbre and picture with slice of hello, something like this. So I want to ensure that the value that I pass, the value that I'm gonna send to AWS is correct. So I do it this way, which is by verifying the argument that I pass to the mock, like this. So I have another assertion that assert that this function should has no error. And I also have assertion to ensure that the parameter being sent to the mock or to the real implementation later on is correct. And after that, as usual, I'm gonna call mock.assert expectation so that this get verified, something like that. So I think that's the all things that I would like to share tonight. This slide will be made available on this link if you want to check that one out, but it's not ready now. I'm gonna need to push that because it's still on my local host. But yeah, thank you for listening to the talk. If you have questions, feel free. Thank you.